The included angle of the two sides of constant equal length s of an isosceles triangle is theta. All right, so let's sketch that out real quick. We have an isosceles triangle. Isosceles means two sides are equal in length and the third side is different. So we'll say this side is length s, this side is length s, and this is theta. Okay, and then depending on the size of the theta, the third side is, we'll call that the base. The third side is changing. So if theta is really big, then your base is larger. If theta is small, your base is smaller. Okay, so now that that's out of the way, part A, we want to show that the area of this isosceles triangle is given by the formula A equals 1/2 times s squared times the sine of theta. So we want to show that that's true. All right, well, let's start with, this is what we want to end up with. So let's start with the formula for area of a triangle. Area equals 1/2 base times height. So let's see if we could figure out a way to replace the b in this formula and replace the h in this formula, because there's no b and there's no h here. So let's see if we could solve for these two things. And we want to bring in a sine of theta, so we definitely want to use some trigonometry, obviously. And so let's, well, we don't have a right triangle here, but let's cut this in half so we have a right triangle, so we could use our definitions. Remember, if you have a right triangle, then we have our definitions of the 6 trig functions. So let's look at half of this triangle. Okay, so this is still s. So this would be half the base, so 1/2 of b. And this would be half of the angle. So let's say theta over 2. Let's make that a little easier to read. Okay, so we have a right triangle. This is half of b. This is still s. And this is theta over 2. Not much better. Okay. So by definition, and so this is the h that we're looking for. So we need the b and the h. So by definition, the way we relate the sides of a right triangle, we have that the sine of your angle, I'll use a different letter for the angle, is equal to the length of the opposite side divided by the length of the hypotenuse. And the cosine of an angle is equal to the length of the adjacent side divided by the length of the hypotenuse. All right, so let's use these trigonometric identities, these definitions. So coming back up here, the sine of theta over 2 should be equal to the length of the opposite side divided by the length of the hypotenuse. Okay, so that's 1/2 of b divided by s. And let's switch to green, let's say. The cosine of theta over 2 should be equal to the length of the adjacent side divided by the length of the hypotenuse. The adjacent side is h, hypotenuse is s. Okay. So this is here. This is here. So now we could solve each of these equations. We could isolate the b and we could isolate the s. So in the first equation, we multiply both sides by s, and we multiply both sides by 2, we'll get 2 times s times the sine of theta over 2 equals b. And if we take the second equation and we multiply both sides by s, we'll get s times the cosine of theta over 2 is equal to h. All right, so now we could take these and plug them in here. So it looks like we'll be swapping out the b and the h for some expressions with s and theta. All right, so area equals 1/2 base times height, or 1/2 times the base, which is given here, 2s times the sine of theta over 2 times the height, which is s times the cosine of theta over 2. So there's 1/2 base times height. It's not exactly what we're looking for, but we're getting there. We've got 2 s's, so there's our s squared, there's a 1/2. Now we just got to deal with this cosine function. And, well, we have 2 times the sine times the cosine. So this 2, this sine, and this cosine, we could apply the double angle formula. Double angle formula, which is 2 times the sine of an angle times the cosine of that angle is equal to the sine of twice the angle. And in this case, if you take twice the angle, our angle is theta over 2. So if you take twice the angle, you get theta, and that's exactly what we want in our formula. All right, so area is equal to 1/2 times s, which is s squared, times the sine of theta. Okay, so check. There is our formula for area. And remember, s is a constant. S is not a variable. It's given in the original problem. It says two sides of constant equal length s. So s is a constant. So we only have 2 variables here, a and theta. A is area, theta is angle. So now, for part B, we want to find how fast the area is changing. So the angle theta is increasing at a rate of 1/2 radians per minute. Find the rate of change of the area when theta is pi over 6. So find dA over dt when theta equals pi over 6 radians and d theta dt equals 1/2 of a radian per minute. Okay, and that's, yeah, that's everything. Okay, so now for the related rates portion of this problem. We haven't done any calculus yet. It's all algebra. And now let's do some calculus. Find the rate of change of area. Okay, so we're going to take the equation that we just derived, A equals 1/2 times s squared times the sine of theta. And we're going to take that, and we're going to implicitly take the derivative with respect to time. Okay, take the derivative of both sides of the equation. So when we have our derivative, well, the derivative of a with respect to time is dA over dt. 1/2 is a constant. S squared is a constant. So we'll take the derivative of the sine of theta with respect to t. So the derivative of sine is cosine. And then we'll times the derivative of the inside. So we're using the chain rule. Times d theta dt. All right, so now we could plug in the given values. So now dA over dt is equal to 1/2 times s squared times the cosine of pi over 6 times d theta dt, which is 1/2 radian per minute. All right, so we've got a 1/2. So we've got an s squared. We've got a cosine pi over 6, which is root 3 over 2. And we've got a 1/2. So if we multiply this all out, it looks like we got 3 2's on the bottom. That's an 8. We've got an s squared and times a square root of 3. And are we given units for length here? I don't think so. So we could just say square units. Yeah. So our units aren't, our units for length aren't given, so units squared per minute. All right, and that does it. That does it for this problem.